In this video, we'll talk about how to set prices under capitation, which can be a little bit trickier than setting prices under a fee-for-service regime. So I'll go through a detailed example. All right, let's consider Montana Medical Clinic, MMC. And Montana Medical Clinic has about 1,400 admissions from 15,000 members. They currently reimburse on a fee-for-service basis, and their average revenue that they make per admission for each of these 1,400 admissions is $10,000. The average variable cost is $3,000, and the annual direct fixed costs and overhead is $9 million. So remember, direct fixed costs and overhead are independent of the number of units produced, so it's just a lump sum value. Now suppose that the payer wants to move from fee-for-service to capitation. And the question is, what rate must be set so that we achieve the current profits under capitation? Well, the first thing we need to figure out is, what is current profits? So this is the profit and loss statement under the fee-for-service regime. So we know that total revenues is $10,000 per admission times 1,400 admissions a year. That's $14 million. Total variable cost is $3,000 per visit times 1,400 visits. That's $4.2 million. You subtract total revenues minus total variable cost, and you get that the total contribution margin is $9.8 million. Remember, contribution margin is something that was discussed in week 2, and the per unit contribution margin is just the price minus the variable cost per unit. The total contribution margin is defined as total revenues minus total variable cost. Now, to get to profits, we also have to subtract the direct fixed costs and the overhead. So subtract $9 million from the contribution margin, and we end up with $800,000 of profits. All right, so now going to capitation, we assume that everything else is equal. So all else equal, meaning that the number of visits doesn't change, the number of members doesn't change, the revenue per visit doesn't change, the cost per visit doesn't change. You get the point. What we know is that we need to obtain the same revenue under capitation as we do fee-for-service, and that's because if the number of visits doesn't change, all of the costs will be the same. So in order to obtain the same profit level, we want to obtain the same revenues. So the revenue we need to achieve is $14 million. If we have 15,000 members, that just means that 14 million divided by 15,000 is 933. So we should charge each member $933 per year to make a revenue of $14 million. To turn this into a per member per month basis, which is how capitation is generally reimbursed at, we just divide 933 by 12, and we get that each member should be charged $77.78 per month in order for MMC to make $14 million of revenue per year. So to make this clear, let's look at the profit loss statement under capitation. So this is the projected profit and loss statement. Total revenues is coming from the $77.78 PMPM rate times 15,000 members times the fact that there's 12 months in a year. So annually we get $14 million. That's simply the calculation that we just did. The variable costs of the clinic is still going to be $3,000 per admissions times 1,400 admissions. So it's still going to be $4.2 million. The direct fixed costs and the overhead costs don't change. And the reason why the variable costs are calculated at $4.2 million is because we assume that the admission rate per member is constant. So we assume before there was 1,400 admissions over 15,000 members. So the rate is a 0.093 visit per member rate. And we've assumed that that doesn't change under fee-for-service versus capitation. All right, so what happens if under this capitated plan, we also have a utilization management program that is able to reduce admissions per enrollee. And that's sort of the point of fee-for-service, is that you're giving providers the incentive to make sure that people don't come back. So the more they come back, the more costs you're incurring because you're not being paid sort of at a per visit basis. You're being paid for taking care of the members in general. So the less they use your services, the more profits you make. So say you're able to reduce admissions from a 0.093 rate to a 0.08 rate. And the question is now, what happens to profits? Well, we know profits are going to increase, but by how much? So if utilization were to fall, we know that at the 0.08 admission rate, 15,000 members times 0.8 means that we would have 1,200 visits for these 15,000 members per year. Originally, we had 1,400 visits, so the number of visits is falling by 200. If the number of visits falls by 200, the variable cost will also fall. So the variable cost will fall by 200 times the variable cost, which is $3,000. So the total variable cost falls by $600,000. Revenues stays the same, right? Because revenues is based on the number of members, not based on any number of visits. So the revenue stays the same. The total variable cost falls, and the direct fixed costs and the overhead costs all stay the same. So the only thing that's changing is the total variable costs. So what we can conclude is that if we're able to reduce utilization, then profits would increase by $600,000. So total profits would be equal to $800,000 plus $600,000, giving you a total profit of $1.4 million, which is quite a big increase. We can ask different types of questions. Here's another question that you might be wondering. What if the payer says, no, $77.78, that's too much. We're only willing to pay a PMPM rate of $65. If that's the case, what are the costs that you need to achieve to make sure that you still break even, so you achieve the accounting break-even point? Remember, accounting break-even is from the full cost pricing method where we take into account total costs. All right, so to figure out what the break-even is, that's revenues minus total expenses equals 0. Well, we need to calculate the revenues with the PMPM of 65, and that's going to be $65 per month times 12 months times 15,000 members, and that gives you a revenue of $11.7 million, which is understandably lower than $14 million because you're charging a lower rate. The total fixed costs don't change. That's $9 million. Remember, total fixed costs are independent of the number of visits and the number of members, so it stays the same. The total variable costs, if we were trying to figure out how much we need to make, so the total variable cost must be set so that the variable cost plus the fixed cost equals revenues, right? We're trying to break even. So essentially, if revenues are $11.7 million, fixed costs are $9 million, that leaves us with total variable costs being equal to $2.7 million. Well, 2.7 million total variable costs. Well, how many visits do we have? Well, we have 1,200 visits. That was calculated from the previous slide, which means that each visit can cost only $2,250. And so what we see is that what this analysis is telling us is that if payers want to pay a rate of $65, the Montana Medical Center is going to have to find a way to reduce their variable cost from $3,000 to $2,250 in order to break even. And so the point of scenario analysis, which is what we did over the last 2 slides, is to help decision makers have a little bit more insight as to what happens if maybe utilization is lower or higher than expected. What if costs are lower or higher than expected? How does the PMPM rate need to change to reach a certain profit level? And so these are the types of questions that you can ask and analyze, and I think it's important to know in order to know the answers to these questions in order to make better decisions.